Okay, we're moving on to section 2 of chapter 14, which is surface area of 3 different circular solids. This is the last section of surface area, and then we're going to move on to volume after this. So the 3 different circular solids are as follows. The first type is just your basic cylinder, okay, which looks like that. And so we're looking for the surface area of this thing, and let's start with the lateral area. Remember from the last section, the bases for a cylinder are here and here. The lateral area is the other parts of it, so it's this middle section here. Okay, that is the lateral area. And the way we find the lateral area is we take the circumference, okay, of one of the bases, so one of the circumferences, and we multiply it by its height. And that'll give you the lateral area. Another way to say this formula is 2 pi RH, where again C stands for circumference, H stands for the height, and R stands for the radius. The total surface area of a cylinder is just going to be the lateral area, plus you have to think about how many bases there are in this particular figure. In this case, there are 2 bases, so we add 2 of the circles, one on top, one on the bottom. Okay, the next type of figure is a cone, which looks something like that. And the lateral area for a cone is equal to 1/2 of the circumference times the slant height. Now keep in mind that the slant height for a cone is this part right here. That's the slant height. And it's just going to be, another way of writing this is Pearl or pi RL. I memorized that by remembering the word Pearl. So C stands for the circumference again. This scripted L is the slant height. And again, the R stands for the radius. And so when we're looking for the total surface area for a cone, I'll take that lateral area, which is basically this portion right here, which does not include this part on the bottom, which is our base. Okay, so but if we're doing the lateral, the total surface area, I'm going to have to include, and you have to think about how many bases there are. In this case, there's just one of the area of the bases. And of course, in this case, it's a circular base, so it's just pi r squared. And the last type of circular figure here is, of course, a sphere, which looks something like this. And the lateral area for this and the total surface area are the same. There's no real lateral area, it's just total surface area. And the formula for this is 4 pi r squared, where the r is equal to the radius. Okay, we'll flip over to the back side now and try a few problems using these formulas. Okay, we're on to the back side here. We're going to try 4 problems to practice finding the total surface area. So in this case, we're looking for the total surface area of each of the circular shapes. First one here, of course, is a cylinder, and the radius of the base is 5, and your height is 6, which is right here. And so first thing we need here is to find the lateral area. We need the circumference for the lateral area. So the circumference in this case is going to be 2 pi r, or just 10 pi. And the lateral area is going to be equal to the circumference times the height, or 10 pi times the height, which is 6, or 60 pi. That gives us the lateral area. And then we have to think about, okay, I have to add this base and this base to find the total surface area. So the area of one of the bases is going to be equal to pi r squared, which of course is going to be 25 pi, because our radius is 5, and we need 2 of them. So 2 of the area of the bases is just going to be 50 pi. And then I just add 50 pi plus the 60 pi, and I end up with 110 pi. Okay, moving on to the second problem here. Is this cone here with a radius again of 5 and the slant height equaling 6. And so the lateral area in this case is just going to be pi RL, and that's going to be pi times the radius, which is 5, times the slant height, which is 6. And so that's going to be 30 pi. And I need to add the base, so the area of the base is equal to, again, 25 pi. Add those together, so the total surface area is equal to 55 pi. And moving on to the last one here, on the top row here, this is the sphere with a radius of 5. So we know the area is equal to 4 pi r squared. So it's 4 times pi times 25, or the total surface area of this is just going to be 100 pi. And so now let's put it together into one large figure like this. I'm going to have to give it a little bit of, draw a little bit of stuff in here and give it some dimensions. So it's actually missing a half a sphere on top there, or a hemisphere. And we know that the diameter of this bottom is going to be 6. So I know that this radius will be 3. And I know that this slant height here is 5. So that's my slant height. And I know that from the very top of this figure all the way to the very bottom of this figure is going to be 17. So there's some things I need to kind of figure out here. I know that if I draw in an altitude here, this is going to be 3, this will be a 3, 4, 5, so this height is 4, so this portion right here is going to be 4. I also know that if this is a hemisphere, that this dotted distance is also a radius of 3, so I know that this portion right here is 3. So then I know that this middle section here must be 10. So that's going to be this height of that cylinder here. And I'm looking for the total surface area of this thing, and I have to recognize here that there's portions of this, okay, that I cannot touch, and so therefore I'm not going to include it in my total surface area. So for example, normally I would include this base in this hemisphere or on the top of the cylinder, and also this base, which is the top or the base of the cone, but also the base of one of the bases of the cylinder. I don't have to include those in my calculations, and I don't want to, in fact, include those in my calculations for the total surface area of this figure. Okay, so since I can't touch it, so let's break down each part separately. The hemisphere, the surface area of the hemisphere. It's just going to be 1/2 of the surface area of a sphere, from 1/2 of 4 pi r squared, or 2 pi r squared. And so it's going to be 1/2 of 4 times 9 pi, like this. And so the final answer to this portion of it would just be 18 pi. So that's going to be the area, the surface area of the hemisphere. This middle section here is just going to be the same thing as the lateral area of a cylinder. And we know that the lateral area of a cylinder is just the circumference of the base times its height. And so it's circumference times the height. Circumference is going to be 2 pi r. So it's going to be 6 pi. And the height's just going to be 10. So this is going to be 60 pi. And that'll be the middle section. And then again, I'm not including the area of these yellow bases, because they're not sections that I can actually touch. And then the bottom here is going to be the lateral area for this cone. So the lateral area for the cone is pi rl, Pearl. And so I know that it's going to be 3 pi, because the radius is 3, times the slant height, which is 5, or 15 pi. I'm going to take these three guys, 1, 2, 3, add them all up to get my total surface area, and I believe you get 93 pi if my calculations are correct. Okay, I'm going to stop right there and let you try some of the homework problems. All right, take care.